Okay, so we're going to try to get through a few examples of polar form of complex numbers. All right, so first it asks us to plot each complex number in the complex plane and find its polar form of r theta and give the argument theta in degrees. So one thing we have to remember is that we need it in degrees and not in radians. And let's get started. So the first one, 1 and I, we graph it. Remember when we're graphing that this is our real axis and this is our imaginary. So our real is at 1 and our imaginary is at 1 also. So there's that point there. Next, in order to find it in forms of r and theta, we know that r is equal to the square root of x squared plus y squared, where x and y are my coefficients of my numbers, right? So my r for the first one would be the square root of 1 squared plus 1 squared, because the coefficient of that imaginary 1 is 1, and that's going to give me the square root of 2. I can't simplify it, so it will stay like that. For for my theta, I have tangent, actually I wrote that backwards. Tangent theta is equal to, actually they want you to find the absolute value of y over x. And so ours is the absolute value of our x and y. Remember, we're 1 and 1, so it's 1 over 1. If I put that in my calculator, the tan inverse of that, it gives me 45. So my theta is 45. So for the first one, let me go ahead and erase some of this. We get root 2, 45 degrees. For the next one, we have just plain old I. So I, if I plot it, let's see if I can change my color. Just plotting on the imaginary 1, this would be where it will be plotted at. For r, we will find it by saying r is equal to the square root of 0 squared plus 1 squared, which is just the square root of 1, which is 1, so r is 1. For our angle, will be tangent is equal to we have 1 over 0, which is 0, so tan inverse of 0. You would get 0, but we have to be, we know we're not talking about the 0, but it would be 90. So if I look at my unit circle, I see that it's actually 90. So I get 190. For the next one, I need to go ahead and distribute this I through. And when I do, I get I and plus I squared. Well, recall that I squared is really equal to -1. So I get -1 plus I. So that means that my x is -1 and my y is 1. So if I plug it into the r formula, I get r is equal to the square root of -1 squared plus 1 squared, oops, plus 1 squared is equal to the square root of 2. And then for my tangent, or for my angle, excuse me, tangent is equal to 1 over -1. And I actually forgot to graph it. We have -1i, so it's right here. Oops. So we can see that it's in quadrant 2. If I look at my unit circle for quadrant 2, when where would I get -1 at? It'll be 135. So let me erase some of this again. It would be root 2 and then 135. The next one is -2, and so there's no imaginary, so I would just stay on the real axis, and so that would be right here. And so for this, it lets me know that x is equal to -2 and y is equal to 0. So if I plug it into my R formula, I get -2 squared plus 0 squared. I don't really need to put that. And then 2 squared is 4, and the square root of that is 2. So R is 2. And then for my tangent, I would have 0 over -2. And again, based on my graph, you can see that it is, where is it? I don't have it again. I'm sorry. Okay. So it's right there on that axis. And from our knowledge of the unit circle, we know that this is 180. So again, we get 2 180. All right, and for the final one, a little bit more difficult for me to graph, but we can try. So this time the imaginary is at -1 and it's at √3, so a little bit under the 1 that we had it at. So it's somewhere in there. Our x value is √3. Our y value is -1. So r is equal to the square root of √3 squared plus -1 squared, which is the square root of 3 plus 1, which is the square root of 4, which is 2. So r is equal to 2. Then tangent of theta is equal to -1 over √3, which we all know is just -√3 over 3 when I simplify it. And when I plug that in my calculator, I get -30. So 2 -30. Okay, let's go on. All right, the next one says compute and convert to RCIS form. So first we have -2 minus 2i divided by 1 minus 2i. So I have to simplify this. And I have to simplify this by multiplying by the conjugate. So let's do that. I'm going to multiply 1 plus i. So this is a little bit from memory now. And I know that when I do that, well, let's do the top first. So -2 times 1 gives me -2. -2 times I gives me -2i. -2i times 1 gives me -2i. And -2i times I gives me -2i squared. And we'll come back and simplify that. And then here we know the difference of squares is really just the first square minus the second squared. So that's minus I squared. So now if we come over here and simplify, we have -2 minus 4i. Recall that I squared is really -1, so that's going to give me -1 times -2, which gives me +2. So that means my 2's actually are going to cancel out. 1 squared is just 1. I squared is -1, so that's going to be 1 plus 1. So I get -4i over 2, and that gives me -2i. So then I need to find out what r is. So again, we know that x is 0, y is -2. So we get r is equal to the square root of 0 squared plus -2 squared, which is going to give me 2. And I'm going to come up here. So tangent theta is equal to 0 over -2. And so just thinking about where this is actually graphed at to help us with the figuring out the angle. we know that negative 2i is right here. And so that line is on my 3 pi over 2. So that means that RCIS form is going to give me RCIS is 2 3 pi over 2. Okay. All right, then it says compute and convert to RCIS form. So we have 3 minus 2i. So once again, we know that x is equal to negative 3, y is equal to negative 2. So r is equal to the square root of negative 3 squared plus negative 2 squared, which is equal to the square root of 9 plus 4, which is equal to the square root of 13. Tangent, or the angle, excuse me. So tangent of our theta is equal to negative 2 over 3 over negative 3, which is positive 2 over 3. That's not going to give me the angle that I want, though, because it's going to change it to positive. And I know that my angle has to be in, if we look at our 1, 2, 3, 4, we need both to be negative. So here, they're both positive. In this quadrant, we have a negative x and a positive y. And over here, we have negative, negative. So it's in quadrant 3. So because it's in quadrant 3, when I do it, when I do this function, so I get tan inverse. Sorry. I'm sorry, I'm trying to go too fast. Please forgive me, guys. Let me erase this. Is equal to tangent inverse of 2/3. And so when I plug that in my calculator, I get 33 and 69, but 33 and 69 is in quadrant 1. Again, I need it in quadrant 3. So just from our memory of reference angles, I know that I need to add 180 to that to find out what the real angle is. And so when I add 180, I get, so I'm going to say REF because that stands for reference. That's my reference angle. My angle is actually going to be 213. So I get 13 and 213, 69 degrees. All right, hopefully we have time for one more. All right, so change to rectangular form. Oops. All right, so here's my problem. Change to rectangular form. We know r is equal to 15 and theta is equal to 120. So recall from previous lessons, we have x. Our x value is going to equal to r cosine theta, and our y is going to equal to r sine theta. So we're going to plug in what we have. So our r is 15 cosine of 120, and y is equal to 15 sine, of 120. When I plug that into my calculator, I get negative, x is equal to negative 7.5, and y is equal to, let's round up to 13. So then we can put it in that rectangular form of, right up here, negative 7.5 plus 13i. And I hope that this helps.